Taking the general form of a complex number, let's say z equals a plus bi in rectangular coordinate. If we have z squared, it's easy to compute a plus bi squared, which is equal to a plus bi multiplying a plus bi. What if you are given a higher exponent, let's say z exponent 8? It is very complicated to expand this. So that is when the De Moivre's theorem comes in. What is De Moivre's theorem all about? So the De Moivre's theorem helps us to compute for a complex number in a higher exponent. So the De Moivre's theorem says that the De Moivre's theorem simply says that if z equals r into bracket cos of theta plus I sine of theta is a complex number, and n is a positive integer, then z exponent n equals r exponent n into bracket cos of n theta plus I sine of n theta. This is what the De Moivre's theorem simply states. So before we can compute a given complex number using the De Moivre's theorem, when it is given in a rectangular coordinate, we must first convert it to a polar coordinate. Let's take an example. Given that z equals 2 plus 2 root 3i, find z exponent 5. The very first thing we need to do in the solution of this is we first have to convert this to a polar coordinate, and by converting to a polar coordinate we need our radius and we need our angle. So finding the radius of z equals square root of 2 squared plus 2 root 3 all squared. This gives root of 4 plus 4 into bracket 3. Root of 4 times 3 is 12 plus 4, 16. That gives a value of 4. Let's find the angle. So the augment of z becomes tan inverse of b over a, which is tan inverse of 2 root 3 over 2 degrees. Since this lies in the first quadrant, that means our augment is still 60 degrees. Presenting this in a polar coordinate now becomes z equals r to bracket cos of theta plus I sine of theta. Z equals, we have our radius r to be 4, cosine of theta, and our theta to be 60 plus I sine of 60. We've been asked to find z exponent 5. So z exponent 5 becomes r exponent 5 cos of 5 theta plus I sine of 5 theta. Z exponent 5 becomes 4 exponent 5 into bracket cos of 5 into bracket 60 degrees plus I sine into bracket I sine of 5 into bracket 60 degrees. This gives Z exponent 5 equals, this gives a value of 1024 into bracket cos of 300 plus I sine of 300. This is how to use the Moivre's theorem to find a complex number to any given exponent. Let's take another example. With our second example, we have Z to be equal to negative root of 3 plus I. We will find Z exponent 3. You can go on and try this. We first need our radius, which is root of root 3 squared plus 1 squared. That gives root of 4, which is 2. To find the angle, theta equals tan inverse of 1 on root 3. That gives 30 degrees. This lies in the second quadrant. Negative root of 3 and 1. So in the second quadrant, we subtract it from 180. 180 minus 30, that gives 150 degrees. So our argument here is 150 degrees. We can now represent it in polar form. Z exponent n equals r exponent n cos of n theta plus I sine of n theta. Z, we have our radius to be 2, so 2 exponent 3 cos of 3 into bracket 150 plus I sine of 3 into bracket 150. This gives 8 cos of 450 plus I sine of 450. That is the Moivre's theorem. If you have any question, you can leave it in the comment section. In case you try any example and you find any problem, you can write up in the comment section and I will attend to you.